Welcome to This Explainer. You know the drill. You walk into a lobby, press a lit button, step inside a metal box, the doors slide shut, and boom, moments later you're stepping out hundreds of feet in the air. For most of us, an elevator is just that, a magic metal box. But under the hood, it is an absolute marvel of engineering. Today, we're going to demystify the elevator. We're going to uncover exactly how it works, what it costs to install and run, and finally, we're going to answer that nagging question in the back of your mind. Can it actually fall? Here is a quick look at our journey today. First, mechanics, then history, followed by types and models, costs and energy, and finally, safety. Okay, let's dive into this. Section 1, mechanics. Every single journey starts right here with the control panel. As soon as you hit that call button in the hallway, you're instantly communicating with the absolute brain of the whole system. And it doesn't just make the car go up and down, it processes a massive amount of information. It literally dictates the traffic strategy for the entire building, regulates the car's speed, and figures out those incredibly precise stops so the floor of the cabin perfectly aligns with the hallway. Once this brain gets your command, it immediately signals the traction machine to get to work. Now, as that traction motor turns, it relies on this brilliant mechanical relationship. On one side of the system, you've got the cabin. That's where we stand. On the other side, connected by thick steel cables looped over a pulley, you've got the counterweight. It works exactly like a giant playground seesaw. When the cabin goes up, the counterweight goes down, and vice versa. It's absolute genius because it heavily offsets the weight of the car and the passengers. The electric motor doesn't actually have to lift the whole weight of the elevator from scratch. It just provides a little bit of extra push to tip the balance. So, putting it all together, the exact mechanical sequence of your ride goes something like this. Step 1, the control panel signals the traction machine. Step 2, the motor kicks in and begins to turn the pulleys. And step 3, those heavy-duty steel traction cables smoothly lift the cabin into the air while that heavy counterweight simultaneously descends. It's this seamless, highly coordinated dance of heavy machinery that makes the whole box move vertically with almost no effort at all. Let's move to and see how this builds. Section 2, history. You know, you might think of elevators as this super modern invention, but humanity has actually been trying to lift things efficiently for a long, long time. Take a look at this timeline. Way back in the 3rd century BC, the Romans were already using manual winches powered by water, animals, or human labor to hoist heavy materials. Fast forward to 1743, and King Louis XV had a so-called flying chair installed at the Palace of Versailles, mostly so he could secretly visit his mistress. But the real game changer, that hit in 1853 when Elisha Graves Otis introduced the safety brake. Before Otis, if a hoisting cable snapped, the platform just crashed. Otis's brake completely prevented this, which is what finally made passenger travel truly viable. Right after that, in 1880, Werner von Siemens brought out the first electric elevator, paving the way for the high-speed systems we ride today. Section 3, types and models. Now, what's really interesting about this slide is how the height of a building completely dictates the technology used. We generally see 3 main types out in the wild. First, hydraulic elevators. These actually push the car up from below using a fluid-filled piston. They're great for shorter buildings, up to about 18 meters, traveling at a max of 60 meters per minute. Then we have machine room traction elevators. These use the cables and counterweights we just talked about, but they require a dedicated room at the very top of the building to house all of those heavy motors. This allows for much higher speeds and distances. But check out that third column, machine room-less elevators, or MRLs. These are fascinating because they ditch that bulky rooftop room altogether by fitting the motor directly into the elevator shaft itself. They can travel up to 75 meters at speeds of 150 meters per minute, and they've basically become the modern standard for mid-rise buildings. To ground all this engineering in some tangible, everyday data, let's look at the strict dimensional and speed standards that dictate your daily commute. Your typical conventional elevator moves at a brisk 1.0 to 2.5 meters per second. And the physical space inside? Tightly regulated. For a standard 6-passenger or 450-kilogram capacity elevator, the floor space absolutely must be at least 1,000 by 1,250 millimeters. Bump that capacity up to 8 passengers or 600 kilograms, and you need at least 1,100 by 1,400 millimeters. These incredibly strict standards are exactly what ensure our comfort, our accessibility, and our safety.
If you enjoyed discovering something new, consider subscribing to Explained Things. There's always something interesting waiting to be explained.
Section 4, costs in energy. As you might guess, there is a stark pricing contrast depending on the sheer scale of the project. For a smaller 2 to 3 story building, installation costs generally range from 30,000 to 80,000 reais. But for a larger commercial building, that number jumps significantly, starting at 70,000 and reaching all the way up to 200,000 reais. So why the massive range? Well, customization, material quality, the sheer number of floors being accessed, and those advanced safety features all drastically alter the final installation price. And mind you, that's before even factoring in the ongoing maintenance fees. And this brilliantly illustrates the real financial drain here: energy. 75. That is the exact number of 100-watt light bulbs you would have to turn on simultaneously just to equal the energy consumed by a single average elevator. Because of all that heavy lifting and the constant electrical draw from the control panels and motors, an elevator can actually eat up to 6% of a condominium's entire monthly budget. That is huge. Section 5. Safety. Okay, I want you to ask yourself this exact question right now. What is the true probability of an elevator completely failing and just free falling down the shaft? We've all seen it a million times in action movies, right? The cable snaps, sparks fly, and the car plummets. Well, take a deep breath, because the actual probability is practically zero. Let's completely bust that freefall myth right now by looking at the fail-safes. First off, elevators do not just hang from one flimsy cable. They use anywhere between 3 to 8 individual heavy-duty steel traction cables. And here's the absolute kicker: just a single one of those cables is strong enough to hold the entire weight of a fully loaded elevator all by itself. But let's play devil's advocate. Let's pretend something absolutely impossible happens and all 8 thick steel cables magically snap at the exact same time. The elevator still won't fall. Why? Because of an ingenious mechanical device called the speed governor. It constantly monitors the car's descent. If the speed ever exceeds a predetermined safe limit, the governor instantly, purely mechanically, forces heavy safety brakes to wedge against the guide rails, locking the car firmly in place. So, the crucial point is really captured in this statistic. Out of 18 billion elevator trips taken annually in the United States, there are only about 27 fatalities. 18 billion trips, only 27 fatalities. Statistically speaking, when you step inside an elevator, you are standing inside the single safest method of transportation in the entire world. It's mind-blowing. Which leaves us with this final thought. The real danger isn't broken cables, but human error and poor maintenance. The ultra-rare accidents that do occur almost never involve snapped cables. They happen because impatient passengers force doors open, or, far more commonly, because building owners hire unqualified technicians who just do a terrible job with maintenance. So, the next time you step into that metal box, you can completely stop fearing a cinematic freefall. But perhaps you should start asking your building manager when the elevator was last serviced. Because as we've learned today, the engineering itself is basically flawless. It's completely up to us to maintain it. Thanks for joining me on this explainer. I really hope you never look at an elevator this same way again.